In an AC circuit, it's necessary to determine how the components of the circuit react to the changing waveform. And for the resistor, we assume that the resistance of the resistor doesn't vary with the frequency, so we don't have to take into account the frequency. So the resistor value is just going to be 3 ohms. Okay, so we don't really have to do anything with the resistor. However, for the inductor and the capacitor, both of these components, the way they react to the current that's applied across them depends upon not only the value of the inductor or the capacitor, but it also depends upon the frequency as well. So for the reactance of the inductor, let's look at that first. The equation for that, as you'll recall, is omega times L, or 2 pi f times L, because omega equals 2 pi f, or 2 pi times the frequency. Remember that omega is what we call the angular frequency, and so it's related to the frequency in hertz by a factor of 2 pi. So frequency is the frequency in hertz, where the angular frequency is in radians per second. Okay, so they're the same thing. They both mean frequency, but the angular frequency, if you want to think of it as the cycles, would be the circle being drawn. So we're just taking our frequency in hertz and multiplying it by 2 pi to get that. So that's the relationship between the angular frequency and the frequency in hertz. So if you're given the angular frequency, omega, which we are here, the 754 radians per second, that comes straight out of our sinusoidal equation, then we would use the omega times L equation to find the reactance. If we had the frequency in hertz, we would use the 2 pi f times L. They're both the same equation. Okay, so as you can see, to find the reactance of my inductor, I have to multiply the 754 radians per second by the 9.29 millihenries that I have for my inductance. And that gives me a reactance of 7 ohms. Remember, reactance is measured in ohms. Okay, it has, we call it capital X, and it would be either X sub L for an inductor or X sub C for a capacitor, and it's measured in ohms. Okay, so for the capacitor, we're going to have to find the reactance of the capacitor as well. And the capacitance is 442 microfarads, and the equation for the reactance of a capacitor is 1 over omega c, or 1 over 2 pi f times c. Again, omega is just 2 pi f, so we're just substituting 2 pi f for omega in that equation. Again, since we have that omega is 754 radians per second, we're going to use that equation. Okay, so here, as you can see, we're going to substitute our 754 radians per second times 442 microfarads into our equation, and we see that X sub C, or the reactance of the capacitor, is 3 ohms. And that's how we find reactance for each of our components. For the resistor, it doesn't vary with frequency, so we just leave that alone. For the inductor, we are multiplying the frequency by the inductor value. And for the reactance of the capacitor, we're multiplying the frequency times the capacitor value, but then we have to invert at the end. And we will talk about that more later.